Okay, so today what we're talking about is the binomial theorem. Binomial theorem. And what the binomial theorem is going to help us to do is to deal with things, binomials, two terms, right? Binomials like a plus b, that's a binomial, two things, a plus b, that's a binomial, two things, to some power, to the n power. And what we're going to use, the binomial theorem, we're going to use to get the answer in expanded form. Okay, so examples 1, 2, 4, we're going to come back to. They're actually the easy ones. They really are. Let's look at example 5. So right off the bat, expand. So remember, we started with, okay, it is to the fourth power. So if we look at our notes from our reading, we're going to go, if it's 4, we're going to go 4, 3, 2, 1, none, right? So it's the fourth power, right? And then we're going to go 0, 1, 2, 3, 4, right? So instead of a and b, we have just x and y. So let's start right off the bat with x to the 4, y to the 0. Of course, somebody's going to ask Mr. Davies, do we have to write y to the 0? No, you don't. I just like to write it, okay? Because that way you see how it works, okay? I'm going to do an x to the 3 and a y to the 1 because I need the exponents between the two to make 4, right? I'm going to go x2, y2. Okay, I'm going to go x1, y3. And then finally, I'm going to do x0, y4. So, the binomial theorem said that we need to make sure it's going to be the fourth power. So, my first term went 4, 3, 2, 1, 0, right? Easy. And then the second term started 0, 1, 2, 3, 4. Because we are doing to the fourth power, my exponents must add up to 4. Thumbs up? Okay, pretty easy so far, right? Now, there are numbers in front. So the numbers in front we get from Pascal's triangle. So let's look at Pascal's. Pascal's triangle. Okay, so Pascal's triangle we made in our reading. Here's Pascal's triangle. And the way you make it is you go 1, 1, 1, and then you 1, 2, 1, and then you add. 1 plus 2 is 3, 2 plus 1 is 3. You add 1 plus 3 is 4, 3 plus 3 is 6, and you just keep making the triangle. Why do we make the triangle? Well, we want the numbers in front. The numbers in front of here, since it's to the fourth power, we just go to the fourth row. Here's my fourth row. Okay, this is my fourth row right here. So the numbers I put in front are going to be a 1, 4, 6, 4, 1. And I'm almost done. I really am. So the fourth row of Pascal's triangle, let's put a 1, a 4, a 6, a 4, and a 1. And let's separate them by plus signs, right? Because you're going to add all these terms. So we'll go plus, 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 plus. Okay, now that's correct. But we can tidy that up. We can, okay? Anything with 0 power is really 1. It's just going to disappear, okay? So let's tidy it up. So if I've got the answer, just going to tidy it up. So I'm going to call it just plain old x to the fourth plus a 4x cubed y plus a 6x squared y squared plus a 4xy cubed plus a y to the fourth. Now, it may seem like, no big deal, but really if you had to do this problem the long way, you would have to write it out 4 times and multiply and multiply and multiply and multiply, right? That's the answer. Snap, right? Easy. Isn't that a cool little theorem? I suppose. If you had to do this the hard way, it's pretty easy, okay? All right, now, let's do a hard one. Now, that wasn't so bad, was it? Now, the next one, we have to be really careful on what we keep track of. So, are you ready to turn the page? And we'll come back to these, okay? Okay, now, so this one's to the third power, but we've got some extra stuff. So before we do anything, I want you to look at this. We're going to let A is really going to be 2x, and B is going to be a negative 3y, okay? So instead of A's and B's, so if I go to my, remember that we did the A's and B's, right? Let's just think about it as A's and B's first, and then we'll substitute in what A and B are, okay? So before we do anything, let's just do it in terms of A's and B's. So we do know if it's the third row, we're going to go A to the third, B to the 0, plus a to the second b to the 1 plus a1 b to the 2 plus a0 b to the 3, right? Now we're going to put in the x and y's here in a bit. But for right now, just let's use a's and b's, okay? Let's just start right there, okay? Then the next thing I want to do is get Pascal's triangle involved. So it's the third row, right? So I'm going to use these numbers, 1, 3, 3, 1, okay? So I'll put those numbers in, okay? Third row, 1, 3, 3, 1. So let's put in our 1, 3, 3, 1. How am I doing? Thumbs up? Thumbs up? Okay. Now, the problem doesn't have to do with a's and b's at all, does it? In fact, the problem has to do with 2x and 3y, right? So let's substitute that back in. So instead of writing a, we're going to write a 2x. Instead of writing b, let's write the negative 3y. So here's where it gets a little tedious. We have to be careful, okay? So I'm going to write 1 parentheses. I need to put the 2x right there, okay? Cubed. Mia. Oh, sorry, there you go. Yeah, thank you. Keep me, I can get off track. Not even know what I'm doing that. Thanks for me. Yeah. Now, I can drop the b to the 0. You okay with dropping that one? Is you okay with dropping that just because I don't need it, right? Plus 3. A is 2x squared, and b is a negative 3y, okay? How am I doing? I just plugged the 2x there and the 3y there, okay? Capiche? Okay, then plus 3. Let's put the a in here, parentheses 2x. That's my a. I plugged that in. And let's put my b in as a negative 3y squared. How am I doing? Okay? Squared here, but the next one's going to be cubed. Yes. And then plus 1. And I don't really need the a to the 0. You guys okay with that? We don't really need it because it's just going to disappear anyway. And then we're going to do our negative 3y, Aaron, cubed, right? There you go. Now, that is technically the right answer, but it's a mess. So can we fix this, okay? We can. You ready to fix it? So, 2 cubed. What is 2 cubed? Don't say 6. 8. So we're going to have a 1 times 8. We're going to have an 8. Okay with the 8? X cubed. You all right with that? 2 cubed is 8 times 1, okay? Plus 3 times. What's 2 squared? 4x squared times a negative 3y. And I'm going to come back and tidy that up, okay? I'm going to try and go step by step so I don't confuse anybody, okay? Plus 3 times 2x. And what is a negative 3 squared? Negative 3 squared? Positive 9. So we have positive 9y squared, right? Plus, what's a negative 3 cubed? What's a negative 3 cubed? Negative 27 y cubed. Okay, I am so close to being done. The last thing I'm going to do is tidy up these numbers. Okay, I'm going to multiply, okay? So the last thing I'm going to do is multiply these numbers. I'm going to have it. Believe it or not, this is a pain, but it's not half as much pain as having to multiply it all out. Do you agree with that? Okay, so then, let's finish this up. I'm going to have an 8x cubed, right? 3 times 4 is 12. 3 times 4 is 12 times negative 3 is a negative 36x squared y. Okay, take a look at that. 12 times negative 3 is negative 36x squared y. Got it? You're going to get the negative 36x squared y. 3 times 2 is 6. 6 times 9 is 54, right? So I have a positive 54x y squared. And then that's just minus 27y cubed. It's a pain, yeah, but it's a lot better than multiplying it all out, okay? And you're going to make less mistakes doing it this way, you agree? Unless 2 cubed is 6, then you're going to make a mistake, right? Okay, now let's flip it over and do the easiest stuff, okay? You want to do the easy stuff? Okay. So, example 1. It's just FOIL, right? So what are we doing? We're just multiplying polynomials, say. So 2x times 4x is an 8x squared, right? 2x times negative 5 is a negative 10x, right? Plus a 12x. You see, I like to line them up. You don't have to. I just like to line them up. Minus 15. Okay, how am I doing? You guys have foiled lots, right? You know how to foil. And then finally I should get an answer of an 8x squared plus a 2x minus 15. Thumbs up. We've been doing that. We did that in Algebra 1, right? Everybody agree with that? Okay. Okay, number 2. Number 2. Let's distribute it. This times this, this times this, this times this. But let's add exponents, okay? All right, we're going to add exponents. So we're going to get a 8 x to the third. You see the x to the third? X to the third, y to the fifth. Okay, I'm adding exponents, right? Plus 20 x squared y to the sixth, right? Plus 12 x to the third y to the third. Okay, we've done that before, haven't we? Maybe not as big, but we did that stuff in Algebra 1. Thumbs up, sideways, where are we at? Napping? We're good? Okay. All right, got 2 more to go, okay? Example 3, okay? It's just a big FOIL. In fact, you really can't call it FOIL because FOIL is first, outside, inside, last, so it's really basically distributive property. Okay, you ready? We're going to take the x times all 3 terms. Then we take the negative 2 times all 3 terms. Okay, that's all we're going to do. Then we're going to tidy it up. Okay, so x times 3x is a 3x squared. X times a negative x makes a negative x cubed. X times 1 is a positive 1x. Alright, this times this is a negative 6x. I'm going to put that right there, okay? Negative 6x, I'll put that right there. Negative 2 times a negative x squared is a positive 2x squared, so I'm going to put that right there, positive 2x squared. And then negative 2 times 1 is a negative 2, okay? So I'm going to tidy it up, okay? So I really want to keep it in order, though. I mean, I want to put the x cubed first, all right? I mean, I like it in what we call descending order. So I'm just going to write this one first. Negative x cubed goes first. Then I'll add these two, positive 5x squared. Then I'll put the x's together, negative 5x minus 2. Thumbs up. Okay, I see 1 thumb up, 2, 3. Okay. All right, last one. And I am going to get out a separate sheet of paper because I think I'm going to run out of room, okay? But if you can write small enough, then you can get it, okay? I'm going to get another piece of paper out because it's going to be big. Sorry. So what are we going to do? I've got to go, you ready? The 2x squared times this, this, and this. Then I got to go the 5x times this, this, and this. Then I got to go the negative 1 times this, this, this. Sorry, there's no shortcuts. It's just a pain. I wish there was a shorter, fast way, but let's just get started, okay? 2x squared times x squared is a 2x to the 4th. Okay? 2x squared times 2x is a positive 4x cubed. 2x times 5 is a negative 10x squared. So far, so good. All right? It's not hard. It's just tedious. Okay? All right, now, let's take the 5x. 5x times x squared is a positive 5x cubed. Let's put that there. Positive 5x cubed. Line them up, right? Make it easy for myself. 5x times 2x is a positive 10x squared. Line them up. 5x times a negative 5x, a negative 25x. How am I doing? I don't know. Now we're almost there. We're getting close. And then I'm going to go negative 1 times x squared is a negative 1x squared. Put that there. Line them up. And negative 2x. Put it there. Line them up. And then a positive 5. Now, when I add them all up, I'm going to get a 2x to the 4th plus a 9x cubed minus a 1x squared minus a 27x plus 5. How's that? Do you have a headache yet?
It's not bad when you line them up.
Yeah, that's the way I like to do it. I mean, that's